In this video, we're going to look at graphing lines. Lines come from linear equations, linear meaning simply a line. But first, it's important to know something about fractions. So before we do that, I want to look at a couple of properties about fractions. Notice if I take 2/3, so I'm just making up some random fraction, it doesn't matter which one I choose, and I multiply this by -1 over -1. Is it going to be mathematically equal or different? Well, -1 over -1, anything divided by itself equals 1. So I'm really just multiplying 2/3 by 1. So whatever I get out here is going to be the same thing, even if it looks different. A little memory aid if you're not really good at the whole negative times a positive is a negative and stuff. Draw a triangle and put a plus in the top and minuses in the bottom. And you can always use this. A positive times a negative is a negative. Positive times a negative is a negative. Doesn't matter which way you go. But also a negative times a negative is a positive. It doesn't tell you that a positive times a positive is a positive. But we've been doing that since elementary school, so that one's not an issue. It's only an issue when you have two negatives or a positive and a negative. Okay, a negative times a positive is a negative. 1 times 2 is 2. Negative times a positive is a negative. 1 times 3 is 3. And notice that these are absolutely equal. Let's look at one that maybe already has a negative in it. And let's do the same thing. Well, a negative times a negative, according to this, a negative times a negative is a positive. 1 times 2 is 2. Negative times a positive is a negative. 1 times 3 is 3. And we see these are equal. So what's the moral of the story? You can take any fraction and basically you can flip both signs. If you flip the top and the bottom both, you have not changed the fraction. It is still mathematically equal. It just looks different. So 2/3 is the same as -2 over -3. And here I have the negative in the top, but if I choose to put it in the bottom, that's okay. I still have equality. One last thing. Let's take Okay, so here I have a negative, and I'm going to say 2 over 1, which we know is 2. Uh, is that the same as, instead of putting it on the side, can I put it in the top, or can I put it in the bottom? Is a negative on the side the same as putting it in the top or in the bottom? Well, here we know this is going to be -2. That's pretty obvious. 2 over 1 is 2. And it's just -2. Here we have a negative divided by a positive, 2 divided by 1, positive divided by a negative, 2 divided by 1, and we see that all of this is equal. In other words, you can take any fraction in the world, and if it has a negative, you can either leave it on the side, or you can put it in the top, or put it in the bottom. They're all the same thing. Well, for what we're going to do here, it's more beneficial to have the negative either in the top or the bottom if there is one. So now let's go ahead and do some graphing. So when you first learn to graph, often you're taught to do a t-table. And so that's what I'm going to do. But we're not here to graph with t-tables. I'm just going to use the t-tables to make a point. Then we're going to learn a better way. So let's make a t-table, and I'm just going to pick some random values. I'm just going to use -2, 0, and 2. I'm going to keep doing that all the way through. And let's start with the equation y equals x, the most basic equation you could possibly have. Okay, well, t-table means I'm going to plug in -2 for x and see what y equals. Well, if I plug in -2 for x, y is going to be -2. If I plug in 0 for x, y is going to be 0. And if I plug in 2 for x, y is going to be 2. In other words, it comes out unchanged in this case. So if I graph these points, and also keep in mind that read a t-table just like you read ordered pairs. They're the same thing. So if I graph these points, remember, x is always on the left, y is always on the right. So this means 2 to the left because it's negative. So I go to the origin, I go 2 to the left, and I go 2 down. And I've graphed that point. Now if I go to the origin and I go 0 x's and 0 y's, I get a point here. If I go to the origin and I go 2 x's right and 2 y's up, because they're both positive, we can see this line forming up. And I want you to notice something here. What number is in front of x? What's the coefficient of x? Well, some people might think 0, but it's not 0 or there would be no x there. It's 1. And the coefficient of x is always the slope. We call the slope m commonly, and here the slope is 1. Okay, I want you to look at what this slope does, how it ties in with what's going on down here. This is not a fraction. Make it 1. Anytime your slope is not a fraction, make it 1, because that's the only way slopes make sense. Slopes are basically a ratio of y movement over x movement. Always remember, x movement is on the bottom. Don't get those mixed up or your graphing will, you'll make mistakes. You'll have exactly the opposite of what you should have had. Y is always on top. Oh, that's supposed to be, I don't know why I wrote a 2 there. Okay, well now look what happens here. This x movement is positive 1. That means 1 to the right on the x-axis. And it's 1 positive y. That means 1 up, because the y-axis goes up and down, and positive is up. Well, notice if I'm at a point on the line anywhere, if I go 1x over, 1y up, I'm still on the line. 1x over, 1y up, I'm still on the line. And so you can always see the slope in action when you have a line there. Let's do another example. Another t-table. And if I plug in these values of x, then I get, I'll leave it to you to verify. I'm just going to do this quickly. Okay. If I plug in -2 for x, that's a negative times a positive. That's a negative. 2 times 2 is 4, and so on. That's again, you can verify. And now if I graph these points, 2 x's left, 4 y's down. And then 0, 0, and then 2 x's over, 4 y's up. We see our line forming up here. And we know these go on forever and ever. I don't always do it, but technically you're supposed to draw arrows at the end. And now I want you to look at the slope here. Well, my slope is 2. That's the coefficient of x. And we make it a fraction. Always make it a fraction, because it's the only way a slope makes sense. According to this, if we're somewhere on this line and we go 1x over, we're going to go 2 y's up. Well, does that happen here? Let's see. Okay, so here I know I'm on the line. I go 1x over, 2 y's up. Sure enough, I'm still on the line. And so you can see the slope actually happening anywhere on here, any place on this line. If I go 1x positive, I go 2 y's positive. 1x positive, 2 y's positive. Let's do another one. So I'm going to keep using -2, 0, 2, but you could use anything you wanted. And if you plug those in, if I plug in -2 for x, -2 times 3 halves is going to be -3, and then 0 times 3 halves is 0, and 2 times 3 halves is 3. If I graph these, 2 left, 3 down. And then 0, 0, 2 right, 3 up. There's our line. And let's look at the slope here. The slope is 3 halves. Well, notice, okay, the bottom is our x's. You'll hear this called rise over run. Okay, y is our rise. Our run is horizontal. That's x. So the run is x. That's horizontal. The rise is y. That's vertical. And notice, if I'm anywhere on this line, if I go 2x's positive, I go 3y's positive, and I'm back on the line. I have another point. If I go 2x's positive, 3y's positive, again, I keep coming back to the line. Notice also, based on the fraction properties we saw earlier, I could actually take this fraction and flip both signs, and it's going to give me the same line, except now you'll notice it's making me sort of think in reverse. I'm going right to left. According to this, since x is negative, that means go 2 left, and since y is negative, that means go 3 down. Does that work? Does it still give me the same line? Well, let's go to a point on the line, and if I go 2x's left, 3y's down, am I still on the line? Yes, I am. If I do it again, 2 left, 3 down, I'm still on the line. So both of these slopes are the same slope, and they give you the same line. Now let's do a negative slope. And if you plug those in, you'll get these points. And so negative 2, 3, that's going to be there. 0, 0, 2, negative 3. And now it gives me a line that's falling. Okay, now you need to know the difference between positive slopes and negative slopes. Notice everything we've done so far, it's always been rising as you read left to right, which is how you always read a graph, left to right. As I'm going through the x's from left to right, y is rising, so it makes a rising line. Notice this slope is positive and our line is going up from left to right. Here we have a negative slope. That means the line is going to be falling from left to right. That always happens. So you need to be able to look at a line like that and say that has a positive slope. You see a line like that, that has a negative slope. Okay, now let's look at the slope here. My slope is, so I have a negative in front, so don't leave it in front. Put it either in the top or the bottom. I like to, most of the time, put it in the top. Now, what this means is if I go 2 positive x's, I'm going to go 3 negative y's. In other words, for every 2 x's I gain, I lose 3 y's. Well, let's look at it. If I'm at the origin, if I gain 2 x's, do I lose 3 y's? Well, yes, I do. Let's think about what if you did 3 over negative 2? Well, we've seen these are mathematically equivalent. Does it give us the same line? Well, it certainly does. This would mean you go left 2 x's, and that would make you gain 3 y's. So if I'm on the line and I go left 2, I gain 3. I go up 3. 2 left, 3 up. So both of these give you the same exact line. Now, what I want to do before I continue with a couple other examples is now we're going to go back and we're going to graph the way I really wanted to teach you. And this is so much faster and easier. So pretend that we haven't done any of this. We're only looking at y equals x. Okay, you could call it 1x, but y equals x. Here is your process. Step 1, get a point. You only need 1 point for this. You don't need 2 or 3 or 4 like we've been doing. Step 1, get a point. Step 2, do the slope. That's all there is to it. I'm going to actually graph this with a different color, and let's see if we get the same line. But you're going to see it's much faster. So I'm looking at y equals x, and I'm thinking, okay, I need a point. So I could plug in any number I want for x. Obviously, it has to fit on the graph, but most of the time, your easiest thing to plug in is 0. Remember that 0 is your best friend in math. It's the easiest thing to plug in. So if I plug in 0 for x, what does y equal? Well, here it's going to equal 0. So I quickly graph that point. I've done step 1. Then I do the slope. I don't need other points. The slope will tell me a bunch of other points. Well, according to my slope, which is 1 over 1, or negative 1 over negative 1, according to this first one here, if I gain an x, I gain a y. So 1 over, 1 up. Gain an x, gain a y. Gain an x, gain a y. And I can get as many points as I want fast. If I want to go the other way, if I lose an x, I lose a y. So I lose an x, lose a y. Lose an x, lose a y. And I can do that again as fast as I want. And then you would draw your line, and that's all there is to this graphing method. So these 2 steps, get a point, and I call the plugging in 0, I call that the fast point. And I always use that whenever I can. Okay, let's do the next one here. Let's pretend this isn't graphed. We're not looking at this. By the way, that is the fast point. I've been using that, but I didn't make a point of mentioning that. But okay, step 1, get a point. Make x 0. If x is 0, what does y equal? Well, 0 times 2 is 2. Put your fast point on there. Now what do? Well, we say, well, the slope is 2, which is 2 over 1. This says if I gain an x, I gain 2 y's. So I gain an x, gain 2 y's. Gain an x, gain 2 y's. 1 over, 2 up. Or if I want to think in reverse, if I go 2 left, I go, if I go 1 left, I go 2 down. 1 left, 2 down. And boom, there's my line. I missed, but you know what I meant. Okay, that's so much faster and easier than the t-table method. So for this one here, my fast point would be 0, 0. Then my slope says if I gain 2 x's, I gain 3 y's. So 2 over, 3 up. If I want another one, 2 over, 3 up. Or I can think in reverse and say if I lose 2 x's, I lose 3 y's. So lose 2 x's, lose 3 y's. Lose 2 x's, lose 3 y's. And boom, we're done. Okay, next one. My fast point is 0, 0. My slope is, so I would be looking at this negative 3/2, and I would immediately put it in the top or the bottom. One helps you go right, one helps you go left. Okay, so remember, this isn't on here yet. We're pretending this isn't graphed yet. So there's only this dot so far. But I go from this dot, which I know is on the line because of my fast point, and this is if I go 2x's positive, I go 3y's negative. So 2x's positive, 3y's negative. 2x's positive, 3y's negative. If I want to go the other way, I can think if I go 2x's negative, I go 3y's positive. So 2x's negative, 3y's positive, another 2x's negative, another 3y's positive, and there's my line. That's how fast this graphing method is. You can literally do it in just seconds. Okay, so to finish up here, let's just start clean with a couple more examples. let's do y equals 3 halves x plus 2. So up to now we haven't had a number out here. Actually there was. It was plus 0. Okay, we could actually go back to all of these that we've done, and we could put a, okay, so y equals x plus 0, y equals 2x plus 0. You know, if there's not a number out here, there really is. It's 0. Why am I making a big deal of that? Because, I mean, you could think, you know, well, that seems kind of stupid. Well, we'll see in a little bit why that number is so important. Actually, I'll say it right now. Notice that this number, whatever number is out here, is always the y-intercept. Let me get a different color. The y-intercept. That's that thing right there. Notice what value of y is getting cut by the graph. Well, it's getting intercepted right there. That is the y-intercept. It's also the x-intercept in this case, but we don't care about the x-intercept right now. The y-intercept, though, is a big deal. Notice this one's getting cut. The y-intercept is at 0 of y. All of these have had a plus 0 out here, and they're getting intercepted at y equals 0. Plus 0. Okay, well now we have one where y isn't 0. Now I'm not going to make a t-table here because we don't care about that anymore. We have a better way. All I want is a fast point. So my fast point is going to be 0, 2. Where did that come from? Well, when I plug in 0 for x, 0 times anything is 0. This whole thing gets eliminated and y equals 2. That's why 0 is so fast to plug in, because it kills whatever term you plug it into, and it just leaves something else that doesn't have a variable. Well, now my fast point is -2. Now I do my slope. My slope says either 3 over 2 or -3 over -2. Well, if I'm at my fast point and I go 2x's positive, I go 3y's positive. That's going to put me right here. Okay, but if, can't see this very well, but let me write it down here. Okay, so I flipped both signs. We saw the properties of fractions that you can always flip both signs, and you have equal stuff. You have equality. Well, according to this, if I go 2 left, I go 3 down. So 2 left, 3 down. 2 left, 3 down. There's my line. That's all there is to graphing with this method. It's very fast. One last example. Oh, also notice what value of y is the intercept. The graph is getting cut here at a y value of 2. Well, there's that number. This number out here is always the y-intercept. It's always going to be the y value of the point where this graph gets intercepted by where the y-axis gets intercepted by the line of the graph. And that's significant. As you get more used to this, you'll start realizing more and more how significant this number is. This number is the y-intercept, and this number is the slope. Those are the two things about linear equations that you always need to know. The slope is the coefficient of x. The y-intercept is the number that's out here. If there isn't a number, it's really plus 0. There is a number there. It's just 0. Okay, one last example. Let's do y equals -1/3 x minus 1. Okay, now I'm going to do this fast and show you just how fast this technique really is. My fast point is 0, -1. There we go. My slope says If I gain 3x's, I lose a y. Or if I'm going the other way, if I lose 3x's, I gain a y. And we're done. That's all there is to this. In closing, I want to point out that when you see these linear equations, they're always based on this form y equals mx plus b. M is the coefficient of x. That's just convention in math. This is the slope. This is the y-intercept. And it's supposed to be an m there. Okay, and so when you look at any linear equation, there's going to be a y out front, then an equal sign, and then some number in front of x. Here, that's negative 1/3. Our slope is negative 1/3. Then we have an x, just like there is here. And then we also have the possibility of a number out here. Here, b equals -1 in this case. So most of the examples, b equals 0. But here b is 2. Here, b is -1.